some physicist way back when, I don't remember when, I don't remember the physicist's name, it's irrelevant, was studying hydraulics. You know what hydraulics? Hydraulics is the movement of fluids in a closed container. So hydrostatics is the study of pressures of non-moving fluids. Hydraulics is the study of pressures of moving fluids. Blood is a moving fluid in a closed circuit. Right? So blood is really governed by hydraulic principles. Now, all we need to know about hydraulic principles is that fluids move from a high pressure area toward a low pressure area. Right? Things always move from a high pressure to a lower pressure. Okay? So that's our driving force. If we can generate pressure, which is what our cardiac muscle tissue does, right, then fluid will move away from the heart because that's where the pressure is going to be the greatest. So that's common sense. That makes sense. This one doesn't make so much sense until we actually start thinking about it. This is the physics relationship of resistance of hydraulics. Okay. It's 8 times the length of the, in this case it would be vessel, times eta, which is a viscosity constant. How thick is the fluid that's moving, right? Pi is a constant, 3.14 and a bunch more, okay? And r is radius, and it's to the 4th power. So radius refers to the diameter of the channel, if you will, or of the tube. L refers to the length of the tube, and eta refers to the viscosity of the fluid. Now, the reason why I had to look this up and I can't remember this is because, does this ever change? No. That's a constant, right? So I don't care about it, right? Does this ever change? Pi? No, that's a constant, so we don't care about that either, right? But these are things now that can affect the resistance to flow. The length of the vessel, the viscosity of the blood, and the radius, to the 4th power, of the vessel. Now, length. This was true with our electrical principles too, right? Resistance was greater the further we had to transmit a signal, right? That was true. So that's true here. The resistance of blood flow in the systemic circuit is much greater than the resistance of blood flow in the pulmonary circuit. Why? Because the systemic circuit is a lot longer. It is harder, if you will, to get blood to my big toe than it is to my ear because it's further. Okay, does that make sense? All right. So that's kind of common sense. Viscosity is the thickness. And the way you can think about this too is like, I mean, you've experimented this, like if you drink through a straw, what's it easier to drink through? A straw that's really short or a straw that's really long? A short straw. Long straw is difficult. You got to suck that stuff up there, right? What muscle did I use? Buxnator, buccinator, whatever. Viscosity, thickness. You ever try to drink milk versus a milkshake? What's easier to drink through a straw? Milk, right? It's less viscous, right? So the viscosity certainly would contribute to this. The thicker something is, the greater the resistance. That make sense?
Yeah.
That's kind of common sense, right? And then diameter, or radius if you will, of the straw. What's it easier to suck something through? A fatter straw or a real skinny straw?
Fatter.
Bigger straw. I mean, there's a point of no return for that where it's actually too big, you can't generate pressure. But this is true too, right? So if things are constricted, smaller diameter, that's going to have a big impact on the resistance to the flow. A larger diameter, less resistance. And the fact that it's to the 4th power doesn't really mean anything except small changes in vessel diameter make big changes in resistance. Right? So we don't have to change the diameter of blood vessels a lot. Just a little bit of change in diameter of things is going to make it easier or harder to move blood. And I think there is. So, in a common sense way, does that kind of make sense? I mean, if you think about it, we're just want to make sure that these are true, and we'll get the physiology behind it here in a minute. Now let's put this in your body. Is this